This tutorial explains what a limiting reagent is in chemistry and covers example questions. The simple equation states that 4 moles of ammonia react with 5 moles of oxygen molecules to form 4 moles of nitrogen monoxide and 6 moles of water. If we wanted to react 400 moles of ammonia, how many moles of oxygen would be required? From the simple equation, we can see that the ratio of ammonia to oxygen molecules is 4 to 5. If we scaled up the ratio by multiplying both sides by 100, we obtain a ratio of 400 moles of ammonia to 500 moles of oxygen. Thus, 500 moles of oxygen molecules would be required to react with all the ammonia. If you're making a chocolate cake, you might have lots of flour because it's very cheap, and so you might have some of it left over, an excess. But what would limit the amount of cake you'd be making? It might be the chocolate, because you couldn't afford to buy as much chocolate as you wanted. In chemistry, the word reagent is just another way of saying the word reactant. So, in chemistry, the limiting reagent, or reactant, is the reactant which is completely used up in a reaction and determines when a reaction stops. If there is any of a reactant left after a reaction, we can say it is in excess. 400 moles of ammonia were mixed with 5 moles of oxygen and they reacted. Is ammonia or oxygen the limiting reagent? We know from before that to react all 400 moles of ammonia it would require 500 moles of oxygen molecules. And thus, not all the ammonia can react, as we have only 5 moles of oxygen. And thus we can say the ammonia is in excess and the oxygen is the limiting reagent. How many moles of ammonia would remain after the reaction? We have a large excess of ammonia, and after we react 4 moles of ammonia, there will be no oxygen left, because for every 4 moles of ammonia which react, 5 moles of oxygen are used up, as stated in the simple equation. 4 moles of 400 moles of the ammonia will react with 5 moles of oxygen, leaving us with 396 moles of unreacted ammonia. How many moles of nitrogen monoxide will be formed? The simple equation states the ratio that reactants react and products form. Thus we will form 4 moles of nitrogen monoxide, because if we look at the equation, 4 moles of ammonia react with 5 moles of oxygen molecules to form 4 moles of nitrogen monoxide and 6 moles of water. 4 moles of ammonia and 6 moles of oxygen molecules were mixed together, and they reacted according to the following equation. 4 moles of ammonia plus 5 moles of oxygen molecules form 4 moles of nitrogen monoxide plus 6 moles of water. However, they were not mixed in the proportions given in the equation, and one was in excess. Which of the reactants is the limiting reagent? First, let's calculate the amount of oxygen which would be required to react with all the ammonia and see if we have enough. From the simple equation, we can see ammonia reacts with oxygen in the following ratio: 4 moles of ammonia to 5 moles of oxygen. Thus, 5 moles of oxygen will react with 4 moles of ammonia. We have enough oxygen to react with all the ammonia. We require 5 moles, but have 6 moles, so we can say we have excess oxygen. Thus, ammonia is the limiting reagent. We have tried solving this question one way, considering the amount of ammonia stated in the question. Now let's consider how many moles of ammonia would be required to react with the 6 moles of oxygen, which is the amount stated in the question. From a simple equation, we can see ammonia reacts with oxygen in the following ratio. 4 moles of ammonia react with 5 moles of oxygen. If we adjust the ratio to 1 mole of oxygen by dividing each side by 5, we obtain 4/5 of a mole of ammonia to 1 mole of oxygen. If we now adjust this ratio to 6 moles of oxygen by multiplying each side by 6, we obtain the ratio 4/5 times 6 moles of ammonia to 6 moles of oxygen. Thus we would require 4.8 moles of ammonia to react with 6 moles of oxygen molecules. We only have 4 moles of ammonia, which is greater than the 4.8 moles of ammonia required. Thus, a reaction using up all 6 moles of oxygen cannot occur, and so the ammonia is the limiting reagent and we have an excess of oxygen. If you're happy with the steps above, you could take the number of moles of oxygen, molecules 6, and divide it by the amount of oxygen in the balance simple equation, 5, and then multiply it by the amount of ammonia, molecules in the balance equation, 4, to obtain 4.8. So that's what we just did effectively above as we were adjusting the ratio. Part B. How many moles of water will be formed? The number of moles of water formed will be related to the number of moles of a limiting reagent. From the simple equation, we can see the ratio of moles of ammonia reacting to water molecules formed is 4 moles of ammonia to 6 moles of water. Thus, we will form 6 moles of water from 4 moles of ammonia. Part C. How many moles of the excess reactant remains after the reaction? The number of moles remaining will be equal to the initial number of moles of oxygen minus the number of moles which reacted with ammonia, which was 5. So 6 minus 5 equals 1 mole. A balanced simple equation gives the proportions which reactants react and products are formed. 4 moles of ammonia react with 5 moles of oxygen molecules to form 4 moles of nitrogen monoxide and 6 moles of water. 2 moles of ammonia were mixed with 4 moles of oxygen molecules and they reacted. Is ammonia or oxygen the limiting reagent? This question is asking which of the two reactants will have completely reacted and been used up. Firstly, we can write down the ratio with which ammonia and oxygen react. From our equation, we can see that 4 moles of ammonia react with 5 moles of oxygen molecules. We can take the ratio of 4 moles of ammonia to 5 moles of oxygen and divide it by 2. Thus, 2 moles of ammonia will react with 2.5 moles of oxygen. There are 4 moles of oxygen present, thus all the ammonia can react with 2.5 moles of oxygen, leaving an excess of 1.5 moles of oxygen. Ammonia is the limiting reagent. We have now identified the limiting reagent and the one which is in excess, but let's suppose we start off by considering how many moles of ammonia would react with all 4 moles of oxygen. If we take the ratio of 4 moles of ammonia to 5 moles of oxygen and divide it by 5, we obtain the ratio that 0.8 moles of ammonia react for every mole of oxygen. Now, if we take this ratio and multiply both sides by 4, we can find out how many moles of ammonia are required to react with 4 moles of oxygen. We obtain the following ratio. 3.6 moles of ammonia react with 4 moles of oxygen. Now, as stated in the question, there are only 2 moles of ammonia present. Thus, all the oxygen cannot actually react, so we can say the oxygen is in excess. All the ammonia is used up and is the limiting reagent. How many moles of nitrogen monoxide will be formed? The ratio of moles of water formed will be related to the number of moles of the limiting reagent. The ratio of reacting ammonia to nitrogen monoxide formed is 1 to 1, thus 2 moles of nitrogen monoxide will be formed. 3.40 grams of ammonia and 3.52 grams of oxygen molecules were mixed and they reacted according to the following equation. 4 moles of ammonia reacted with 5 moles of oxygen molecules to form 4 moles of nitrogen monoxide plus 6 moles of water. However, they were not mixed in the proportions given in the equation, and one was in excess. Which of the reactants is the limiting reactant? Secondly, what mass of water will be formed? And thirdly, what mass of the excess reactant remains after the reaction? The molar masses are 1 mole of hydrogen atoms will have a mass of 1 gram per mole of hydrogen atoms. 1 mole of oxygen atoms will have a mass of 16 grams per mole, and 1 mole of nitrogen atoms will have a mass of 14 grams per mole. We can start off by calculating the number of moles of each of the reactants. 3.52 grams of oxygen divided by the mass of an oxygen molecule, so 16 times 2, gives us the fact we have 0.11 moles of oxygen molecules. 3.4 grams divided by 17 grams, which is the mass of an ammonia molecule, 14 plus 1 plus 1 plus 1, gives us the fact we have 0.2 moles of ammonia molecules. The next thing we need to do is identify the limiting reagent. So, to identify the limiting reagent, we can take one of the two reactants or reagents and see if there is enough of the other reactant to use it all up. First, let's calculate the amount of oxygen which we would require to react with all the ammonia and see if we have enough. From a simple equation, we can see ammonia reacts with oxygen in the following ratio: 4 moles of ammonia to 5 moles of oxygen. We can adjust the ratio for 1 mole of ammonia by dividing each side by 4. So for every mole of ammonia, it reacts with 5/4 moles of oxygen molecules. We can now adjust the ratio to 0.2 moles of ammonia by multiplying each side by 0.2, obtaining for every 0.2 moles of ammonia, we require 0.25 moles of oxygen molecules. We have not got 0.25 moles of oxygen, only the 0.11 moles of oxygen molecules we calculated. Thus, oxygen is the limiting reagent, and we have excess ammonia. If you're happy with the steps, you could take your moles of ammonia calculated, 0.2, and divide it by the amount of ammonia in the balance equation, 4, and then multiply it by the amount of oxygen molecules in the balance equation to obtain 0.25. We might also have chosen to start with seeing if there was enough ammonia to react with all the oxygen, or 0.11 moles of oxygen molecules. From the simple equation, we can see ammonia reacts with oxygen in the following ratio: 4 moles of ammonia to 5 moles of oxygen molecules. If we adjust the ratio to 1 mole of oxygen by dividing each side by 5, we obtain 0.8 moles of ammonia to 1 mole of oxygen molecules. If we adjust the ratio to 0.11 moles of oxygen by multiplying each side by 0.11, we obtain 0.088 moles of ammonia to 0.11 moles of oxygen molecules. Thus, we would require 0.088 moles of ammonia to react with 0.11 moles of oxygen molecules. We have 0.2 moles of ammonia, which is greater than the 0.088 moles of ammonia required. Thus, we have excess ammonia, and the limiting reagent is the oxygen. If you're happy with the steps, you could take your moles of oxygen calculated, 0.11, and divide it by the amount of oxygen in the balanced equation, 5, and then multiply it by the amount of ammonia molecules in the balanced equation to obtain 0.088 moles. The second part asks, what mass of water will be formed? The number of moles of water formed will be related to the number of moles of the limiting reagent. If you're good with maths, you will see from the simple equation 5 moles of oxygen molecules form 6 moles of water molecules. So we need to use this ratio of 5 to 6 to calculate the number of moles of water formed. So 0.11 divided by 5 multiplied by 6. If you're not as good at maths yet, what you can do is we'll go through it step by step. From a simple equation, we can see the ratio of moles of reacting oxygen to water is 5 moles of oxygen molecules to 6 moles of water. If we adjust the ratio to 1 mole of oxygen by dividing each side by 5, we obtain 1 mole of oxygen molecules to 6/5 moles of water molecules. We can then adjust it to 0.11 moles of oxygen by multiplying each side by 0.11. Thus, we will form 0.132 moles of water from 0.11 moles of oxygen. The mass of 1 mole of water will be equal to the mass of 1 mole of oxygen atoms plus the mass of 2 moles of hydrogen atoms. So 18. So the mass of water formed will be equal to 0.132 multiplied by 18 giving us a total mass of 2.376 grams. As the data in a question is given to 3 significant figures, you may want to give this answer as 2.38 grams. Part C says what mass of the excess reactant remains after the reaction. We know that the excess reactant was ammonia, and we start off with 0.2 moles of it. Not all of it will have reacted, and in this part here, the second part, after we identified the limiting reagent, we worked out that 0.088 moles of ammonia reacted with 0.11 moles of oxygen. Thus, the number of moles of ammonia remaining at the end is 0.2 minus 0.088 moles, multiplied by the mass of 1 mole of ammonia, giving us a total mass of 1.904 grams. And again, if we're sticking to 3 significant figures, 1.90 grams. What is the answer to the following riddle? What is it that belongs to you but others use it more than you do? The answer in 3, 2, 1. And the answer is your name.